So let's now provide some definition and demonstration for each of these logical connectors. Let's start with the negation. So let's do this by displaying some tables. For example, for the negator connector, or the negation connector, let's say we have these variables, and x is negated on the right side. If we give the input value for x as 0, the return value from the negation of 0 will be 1. The same way, the return value for 1 will be 0. So this one is quite simple. It's the negation of a variable. Moving on. What about the conjunction? So the conjunction for these ones, we can do it like this. And by the way, this is a very valuable way of trying to compound meanings behind complex expressions. Right? Let's say we have this table right here. It's an enormous table. The first column will have so we have two variables, right? We have x and y in this case. Because this operator can be used for single variables. It can also be used for multiple variables. They act in this same way. Like you can have x conjunction y, and if you negate this, it would be the same as saying, let's imagine that we equate x conjunction y to z. Let's call it that. So it will be the same as negating z, right? So if we negate z, we can apply this logic. That's how the negation can be explained in this context. So let's go on to these ones. They're more complicated, but not at all difficult to learn. So if we have, let's give all the combinations for x and y. Let's say 0, 0, 0, 1, 1, 0, and 1, 1. What will how will the behavior of the connector conjunction be? So if we have x and y, right? X conjunction y. What will the defined behavior be like? Well, let's define the conjunction to understand its behavior. The conjunction returns a true or positive or 1 value for the case where both of them are true. That is the only case when the conjunction of these two variables can be 1. Otherwise, if they're different, or if they're not both positive or 1 or true, then they are 0. They are false. The conjunction requires both of them to be 1 or true in order to return a true statement, 1. How about then the disjunction? How will the disjunction work? So let's just say up here that the conjunction requires both to be 1. That's the definition. So then we have the disjunction, right? How will it work? Well, the disjunction is not the opposite of the conjunction. It has a rule set of its own, and that is if any of the variables x or y is positive, and this includes the last scenario where both of them are positive. Say, if any of them are positive, then the outcome will be positive. Since in the first scenario, both are 0, they're negative, they're false, then the disjunction will return false, because not one nor the other are 1 or true. For the next one, you can see that y is 1, so one of them is true, is 1, so the return value will be 1. The same applies to the next, and the same applies to the last one. It can be confusing, but the last one returns a positive value for one of them being true. It is the case. That's the rule set, and that's how we will define it. So how about now, let's look at the implication connector. Let's say x implies y. What will be the return value? When we're talking about the implication, this is saying that given, let's say x is the implicator, right? If the implicator is 0, then the default value will always be 1. The logic behind this is that the implicator has no say on what y can be. So since y can be anything, including a 1, then it shall be a 1. So, and the same applies to the following. In case x has the value 0, again, y, which is 1, it will be 1. The default value for return for a implication that has as an implicator the value 0 will always be 1. So the next one, the rule is, so since x is, or the implicator is 1, the value that is in y will matter. So the value right now is 0, so the return value will be that of y. It will enable, so x by having 1 will enable the value of y to be returned. And the same for the last scenario, the x value of 1 enables the return of the value 1. Now the next connector, right, let's just say here, before we go to the next connector, let's just say that the rule is x enables y, given that by default it returns 1, right? So the default scenario is the returnal of 1 if the implicator is 0. If the implicator is 1, is true or positive, then y will be the return value. So actually, let's rewrite this as in a more logical sense. So if implicator, if it is 0, then default is 1. And we need more space for this, so let's give it the corresponding space. And so if the implicator is 1, then the return value is whatever is in y. Okay, so that's that dealt with. How about now the equivalent sign? So x equivalent to y. This is quite simple. It's just saying that if they're equal, then it must be true. If they're unequal, then it must be false. So this will be true, or 1. These two scenarios will both be false or 0, and this one finally will be 1. They're equal. So let's say that the equality returns 1, while inequality returns 0. So equality or inequality between variables. So that's the definition. And these are the definitions for logical connectors and how they can be applied and the expressions that will follow.